Okay, this is the last section of Unit 3. And now we are solving radical equations. And the key takeaway on this one is that you have to get the radical. Oh, I'm ready. Change it to this. The radical alone on one side of the equation. That's your key goal before you can, and then you'll take the square root. But the first thing to do is get the radical alone. Think of it as like its own entity that's got to be all by itself. So here I have -3 being multiplied by the radical. So to get the radical by itself, I'm going to divide both sides by -3 to undo that multiplication. So that's going to give me the square root of 4x minus 3. -12 divided by -3 is a +4. Then, once the radical is alone, you can square both sides to undo the radical. So when I square a square root, all that does is undo it. So I have 4x minus 3. 4 squared is 16. And then we're going to solve for x. I'm going to add 3 to both sides. So I have 4x equals 19. Divide both sides by 4. So x is 19 over 4. Do not make it a decimal. Do not make it a mixed number. Do make sure it's simplified. Sorry about that. There's nothing that goes into both 19 and 4, so that's finished. Do not make it a decimal. Do not make it a mixed number, but do make sure it's simplified. Okay, so that's your final answer. Okay, next one. I want to get the radical by itself. Before I can undo the multiplication, I need to move the 5 over. So I'm going to subtract 5 from both sides. It's going to give me 2 cube roots of 4 minus 3x equals -14. I want to get the radical by itself, so I'm going to divide by 2 to undo that multiplication. That gives me the cube root of 4 minus 3x equals -7. Now, I'm not going to square it, but I'm going to cube both sides because I'm going to cube it to undo the cube root. So I take that to the 3rd power. 4 minus 3x, because cubing the cube root just gets rid of that radical, equals -3 to the 7th is a -343. Now I'm going to get the x by itself. Subtract 4 from both sides. So that's -3x equals -347. Divide both sides by -3, and x equals 347 over 3, because 2 negatives make a positive. I would leave it as a simplified number. Make sure that you can't simplify 347 and 3, and you can't. If your teacher allows you to make it into a mixed number, it would be 115 and 2/3. Do not make it a decimal, though. So check with your teacher if they'll take the mixed number. I'd like the improper fraction. But either way, do not make it a mixed number, because that does not give you an exact answer. What do you do? It rounds it, so it's not exact. Okay. All right, next one. I want to get the radical by itself. The radical is being divided by 4, so to undo that division, I'm going to multiply by 4 on both sides. So that gives me the cube root of 5x plus 2 equals 20. I'm going to cube both sides. I get 5x plus 2 equals 20 cubed is 8,000. Subtract 2 from both sides, so I get 5x equals 7,998. Divide both sides by 5, and x equals 7,998 divided by 5. That would be an improper fraction that would be appropriate. If you're allowed to do mixed numbers, and 5 goes into 7,998, 1,599 times, and 3/5. Okay, check to see what your teacher will allow you to put, whether it's a decimal, a simplified fraction, improper fraction, or what result it would be. But that's how that would be solved. All right, next one. I've got to get the radical by itself. So I'm going to subtract 2 from both sides. So I have x minus 2 equals the square root of 3x minus 2. To undo the radical, now that the radical's alone, now that the radical's alone, you're going to square both sides. You are squaring this whole thing. When you square that whole thing, that means I have 2 of those parentheses. This is not x squared minus 4. This is x minus 2 times x minus 2. It's two of those parentheses. So you're going to have to FOIL that. X times x is x squared. X times minus 2 is minus 2x. Minus 2 times x is minus 2x. Negative 2 times negative 2 is a positive 4 equals 3x minus 2. That gives me x squared minus 4x plus 4 equals 3x minus 2. I have a quadratic here because I have the x squared term. So what I need to do is set it equal to 0. I'm going to subtract 3x from both sides, and I'm adding 2 to both sides. That gives me x squared minus 7x plus 6 equals 0. I have a trinomial where a is the, my a is 1, so I need numbers that multiply to be 6 and add to be negative 7. And negative 1 and negative 6 will fit that bill, so I have x minus 1, x minus 6 equals 0. Set each factor equal to 0, x minus 1 equals 0, x minus 6 equals 0. Add 1 to both sides, I get x equals 1. Add 6 to both sides, I get x equals 6. And on these square roots, it's going to be really important that you plug it in to see if there's an extraneous solution. So if I plug in 1, 3 times 1 is 3, 3 minus 2 is 1. The square root of 1 is 1, and 1 plus 2 is 3. If I plug in 1 over here, that means 1 equals 3. That doesn't work. So this is an extraneous solution. That's not one of your solutions. If I plug in 6, 3 times 6 is 18. 18 minus 2 is 16. Square root of 16 is 4, and 4 plus 2 is 6. Does that equal 6? It does, so that one works. Okay, plug it in. If it doesn't work, it makes it extraneous. And if you have to write it out and plug it in, this one would have been 1 equals 3 times 1 minus 2. Just plug in that for wherever there's an x. If you're not sure what I'm doing. 3 times 1 is 3. 3 minus 2 is 1. So is the square root of 1 plus 2. Square root of 1 is 1. 1 does not equal 1 plus 2. That's why that's extraneous. When I plug this one in, I got 6 equals the square root of 6. 3 times 6 minus 2 plus 2. 18 minus 2 is 16. So it was the square root of 16 plus 2. Square root of 16 is 4. And 6 does indeed equal 4 plus 2, so that worked. Plug it in, especially on the square roots. On the cube roots, it's not going to be as important because, although you should still do it, all right? Just pay attention and plug it in so that you don't miss points because you didn't find out that something was extraneous. Okay, here we've got 2 square roots. I just need to get one of them alone. So I'm going to focus on this one and get that one alone. So I have x minus 8. I'm going to add the square root of x to both sides. Equals 8 plus the square root of x. And yes, I know there's no way I'm going to get them both alone. That's not going to happen. So just focus on one. I focused on the one that had 2 terms under it. I'm going to square both sides. So I'm squaring both sides here. That's going to give me x minus 8 on this side. On this side, it means I have two of these binomials. So I have 8 plus the square root of x times 8 plus the square root of x. I'm going to FOIL that. 8 times 8 is 64. 8 times the square root of x is 8 square roots of x. Square root of x times 8 is 8 square roots of x. Square root of x times the square root of x is the square root of x squared, which is just x. Now I'm going to combine like terms. I have x minus 8 equals, stay with me, 64 plus 16 square roots of x plus x. Now I only have one square root. Now my goal is to get that square root by itself. So what I'm going to do is I'm going to subtract x from both sides, and I'm going to subtract 64 from both sides. The x's will cancel here. Negative 8 and negative 64 is negative 72 equals 16 square roots of x, because all of this cancels. I want x by itself, so I'm going to divide by 16. And on this one, I'm going to go ahead and take the square root. Negative 72 divided by 16 is negative 4.5, or excuse me, I'm going to use a decimal before I take the square root. Is negative 4.5 equals the square root of x. I'm going to square both sides. If I take negative 4.5 and square it, I have 20.25 equals x. That's my answer. I need to plug it in to make sure it's not an extraneous solution. So if I plug it in to check it, I have, and everywhere there's an x, I'm going to put 20.25. 20.25 minus 8 minus the square root of 20.25 equals 8. 20.25 minus 8 is 12.25, so it's 12.25. Root of 12.25 minus the square root of 20.25. And that's got to equal 8. The square root of 12.25 is 3.5. The square root of 20.25 is 4.5 equals 8. So this says that -1 equals 8. -1 does not equal 8, so that doesn't work. It was the only option I have. It doesn't work, so it's no solution. So be really careful of that. Make sure you plug it back in. Don't assume because there's one answer that it's going to work. You've got to plug it back in to make sure that it works. Okay, we've got 3 more problems. Okay, this time we're going to work with rational exponents. I want to get x by itself. So first, I'm going to subtract 12 from both sides. So I have x to the 3/5 equals -1. To undo a rational exponent, remember rationals are exponents. To undo this fractional exponent, I'm going to take it, raise it to its reciprocal power. And then I'm going to take this side to the reciprocal power. What that does is this cancels everything and leaves me with x on the left-hand side. And then I'm going to use my rules for fractional exponents to solve this. Always do the root first and then the exponent when you're simplifying. So the cube root of -1 is -1. So that gives me -1 to the 5th. And -1 to the 5th is -1 5 times, so I have an odd number of negatives, so that's -1. And that's going to be your solution. Okay, let's try another one. Remember, we're trying to get x by itself. So first I'm going to add the 5 to both sides. This gives me 3 times x plus 4 to the 2/3 equals 48. Trying to get this unit by itself, so I'm going to divide both sides by 3. So I have x plus 4 to the 2/3 equals 16. And now I've got this by itself with a rational exponent. To undo the rational exponent, we're going to multiply by its reciprocal. I'm going to take it to the reciprocal power, and I'm going to do the same thing over here. On the left-hand side, those undo each other, so I have x plus 4. On the right-hand side, remember to solve it, we do the root first and then the exponent. My root is the 2, so that's the square root of 16, which is 4, and then I'm going to take 4 to the 3rd. 4 to the 3rd is going to be 64. And remember, that's going to be, well, let's back up. Since it was the square root of 16 was a plus or minus 4 to the 3rd, that means plus or minus 4 to the 3rd is a plus or minus 64. Because if I cube it, it's going to be positive. A positive, it's positive. If I cube a negative, it's negative. So that means I have 2 answers. I have x plus 4 equals positive 64, and I have x plus 4 equals negative 64. So go ahead and solve that. If I subtract 4 from both sides, I have x equals 60. And if I subtract 4 from both sides on this one, I have x equals negative 68. And those are your solutions for that problem. Okay, we have one more left. Okay, again, we're trying to get x by itself, so that I need to move this 6 over to the other side. So we're subtracting 6 from both sides. So I have -4 x to the 2/5. Oh, that's a 3, not a 5. Let's get that straightened out there. Equals -36. I want to get the x by itself. I need to undo the multiplication, so I'm going to divide. So I have x to the 2/5 equals 9. To undo this exponent, I'm going to raise it to the 2/5, or excuse me, to the 5/2. I'm going to raise it to the reciprocal. And I'm going to do the same thing over here, 9 to the 5/2. These will cancel each other out, so I have x on the left-hand side. On the right-hand side, I'm going to do the root first. The square root of 9 is plus or minus 3. And then I'm going to take that to the 5th power. 3 to the 5th power is going to be 243. If it's a positive 3, it'll be positive 243. Negative 3 to the 5th power is a negative 243. So that's your final answer. Okay, so there's quite a bit of homework there. Follow whatever your teacher's instructions are on that homework, and that's the end of that last unit of, or that last section of Unit 3.